Good day. Welcome back to lesson 4 of grade 12 inverse functions. In this lesson, I'm going to discuss with you 3 different reflections. Let's just look at these reflections. We have the reflection in the x-axis. That is where we replace y with a negative y. We have reflection in the y-axis. That is when we replace x with a negative x. And then we have the reflection in the line y equal to x. And that is where we swap x and y. And that is also, like we said in previous lessons, that is also called the inverse. So reflection in the line y equal to x and inverse, one and the same thing. Let's look at this first problem and see how we're going to do this. Given the functions fx equal to minus 2x plus 8 and gx equal to 3x squared. So this is a linear function and this a parabola. Determine the equation of, and the first question is to find h. And you will notice this is a new function because given to us was f and g, and they ask us to find h. How do we get h? H is the reflection of f in the y-axis. So let's write down our f. So fx is equal to minus 2x plus 8. They want us to reflect it in the y-axis. So that means that x will become negative x. So let's do that. So we say for f, y is equal to minus 2x plus 8. And then we say for h, y is equal to minus 2, and the x now becomes minus x plus 8. So that means y will be 2x plus 8. So our final answer then will be hx will be equal to 2x plus 8. So that is the reflection in the y-axis. In the B part, they ask us to find s, and s is the reflection in the x-axis. Now for a reflection in the x-axis, when we look at a reflection in the x-axis, then, like we said before, reflection in the x-axis, that is when y becomes negative y. So we say y becomes negative y. So 4g is y equal to 3x squared. That is our g function. And now we look for s. And that is where we substitute y with negative y is equal to 3x squared. So that means that y is equal to minus 3x squared. So as you can see, when we reflect the parabola in the x-axis, it will change from a happy face to a sad face. So we can now say that our s function is the function minus 3x squared. Let's look at the next problem. In this question, they say that the graph of fx is equal to a to the x. You notice that this is an exponential graph, but a is not given to us. And this graph passes through the point P, which is minus 2 and 25. G is the reflection of f in the line or x equal to 0. Now the line x equal to 0, you will hopefully agree with me if we look at the drawing. This is the line x equal to 0, the vertical line that cuts the x-axis at 0, and we also refer to it as the y-axis. So this reflection is in the y-axis, and they ask us to determine the value of a. It's now this a they ask for. So let's do it. We're going to substitute that point, we're going to substitute the point P, which is minus 225, into y equal to a to the x. So that means that 25 will be equal to a to the minus 2. And you will remember from exponents, we can write this as 1 over a squared. So that means that a squared is equal to 1 over 25. And that means that a will be plus minus 1 over 5 because we find the square root on both sides. But as you remember from our discussions on functions, is that our a, that base, the base here of this exponential function, must always be positive. It can't be negative. So because of the fact that we found the square root on both sides, and this is a quadratic, it means there are two possible solutions, but we are only interested in the positive solution. So that means a will be equal to 1 over 5. Let's look at B. In B, they say that gx is equal to b to the x. And you will notice this gx was given to us on the drawing as well. That was the f function. It's a decreasing exponential, which you can see that's why the base was less than 1 but greater than 0. And now g is this one. And as you can remember, they said to us before that g is the reflection of f in the y-axis. Remember, x equal to 0 also means the y-axis. So we're going to do that. So we will say that for f, y is equal to 1 over 5 to the x. And now we must reflect this function f in the y-axis. So we're going to reflect in the y-axis. So that means x will become negative x. So to find g, we're going to say that y is equal to a fifth to the minus x, because x becomes negative x. And that means now that y is equal to 5 to the x. So as you can see, it now changed to an increasing function, which is also the case on our drawing, the increasing function. So this is my function g. The question was, they asked us what b will be. So we can now say b will be equal to 5. And that is then number B. Let's now look at C. In C, they ask us for the coordinates of the image of B, and that image of B is on G. So you will remember that B is on function f, and B image is on function G. And to find the coordinates of the image, we must reflect P in the y-axis. So I'm just going to say we're going to reflect in the y-axis, and that is where x becomes a negative x. Now point P is the point minus 225, and now I'm going to find the image of P, and that is where I substitute the x with a negative x. So you will agree we're going to get a positive 2 and 25. So that means the image of P will be the point 2, 25. So now we are ready for number D. Number D says that if H is the reflection of F, so just always read carefully, We want h now. You can see the question is to find the equation of h. But what must we do to get to h? H is the reflection of f in the line y equal to x. So if I find the reflection of f in the line y equal to x, it means we find the inverse. So we can say that now, that for f, because it's f that we need to reflect, and if we did it on the previous page, that the base was a fifth, and now we go for h, which is also called the inverse. In this case, they said that this reflection will give us h. Now to find h, we're going to interchange. So that means x will become y and y will become x. And that is why I've put the double arrow, because we're going to swap. So x will be equal to 1 over 5 to the y. And now we use that log definition again. So we can say that y is equal to log x with a base a fifth. And then we can write it in our fx notation. So we can say that hx will be the function log x base a fifth. And that is then the reflection of f in the line y equal to x. Let's look at the last question here. In this one, they ask us for the coordinates of P double image. You can see with the two little lines there. It means we must find the second, because we already used P image. So now we use this notation to find another image of P. And that image will be on H. Now, to get to H, you will remember we swapped x and y. So x becomes y becomes x. So that means it's a reflection in y equal to x. And to do this, we're going to reflect that point P in y equal to x. And that is where x will become y and y will become x. Now, point P was given to us as minus 225. And now we want P image, and we need to apply the reflection in y equal to x. So that is where x becomes y and y becomes x. So that means the image of P will be 25 and negative 2. So we can write down that the image of P will have the coordinates 25, negative 2. So this was our discussion, so that you just understand these different reflections. Thank you.